The body tanks are located fore and aft of the wing. Except for a 1,000-gallon reserve in the wing tanks, all fuel in the tanks at the time of contact may be used in flight refueling. This fuel is transferred through the boom, which has been modified from the configuration used on the KC-97 by refairing the boom and body boom combination and increasing the area of the renovator for increased stability and maneuverability. The boom operator in the KC-135 lies in a prone position on a platform facing aft toward a window, affording a view of the entire formating envelope. While the first KC-135 airplane was approaching the final stages of its completion, with the hanging of the 4 Pratt & Whitney J57 engines, plans were continuing for the rollout and flight tests to follow, with pilot and crew members employing factory training units as a means of gaining a thorough knowledge of systems and operation. The training unit, which is set up to handle 14,500 man-hours of instruction per month, is equipped with devices simulating all the major systems components of the KC-135, supplemented by over 400 graphic age transparencies. The first phase of the training of contractor personnel began in October 1954, and the majority of the personnel involved with the KC-135 have now received familiarization through the program, which operates as a continuing process, so that as changes are made in the airplane, the current configuration is taught. The initial group of Air Force testing, planning, and training personnel have also received familiarization through this program, which will continue for both flight and line personnel, for instructors at Air Force residence schools, and for members of the Air Force's Mobile Training Wing. Ahead of the first KC-135 on its rollout day lay a series of tests prior to flight. Before taxi tests, the airplane was checked to obtain data on surface hinge moments required to overcome friction. Lateral control is provided by an inboard and outboard aileron and 4 spoilers in each wing. Actuated through the 3,000-pound hydraulic system, the spoilers are positioned by the aileron control system for lateral control and may be operated separately for use as speed brakes. The outboard aileron is connected to the inboard aileron by a bus cable system and to the flap drive so that it will not actuate when the flaps are up, and will operate in conjunction with the inboard aileron when the double-slotted flaps are extended. Directional control is provided by a conventional fin and rudder positioned by a control tab in the rudder trailing edge, while movable elevators provide primary flight longitudinal control, and an adjustable stabilizer accomplishes longitudinal trim. Of the KC-135's 4 jet engines, number 4 is equipped with a self-contained combustion starter and compressed air storage bottle, making it possible to start the engines without employing an external starting source, supplying compressed air which is combined with JP4 from the airplane's fuel supply. Air pressure is bled from the bleed air manifold to start the other 3. For the test program, the KC-135 was instrumented with continuous dynamic recorders and photo recorders. Taxi tests at low and high speeds, begun on August 30, 1956, checked elevator and rudder operation, as well as spoiler and speed brake operation for response to observations by the pilot of any time lag or possible erratic operation. On August 31, the first KC-135 was airborne for its initial flight, manned only by a pilot and co-pilot. Lasting 90 minutes, this first flight demonstrated airplane airworthiness and handling characteristics. In subsequent flights during Phase 1 testing of the KC-135, a series of tests was performed at an altitude of 10,000 feet to demonstrate the effect of flap and gear retraction on longitudinal control and longitudinal trim and control effectiveness. Lateral control effectiveness was also checked. At 15,000 feet, stall investigations were performed with stalling characteristics observed and records made of pitching, rolling, and yawing as stalls progressed, and further tests to determine the airplane's stalling speeds and flying qualities near the stall. Landings were checked to verify landing distances and characteristics, demonstrating the KC-135's tricycle landing gear system, including 2 main gears, each consisting of a 4-wheel truck and a steerable nose gear. The landing gear is actuated for normal braking by either the pilot's or co-pilot's rudder pedals. At the Boeing Refuelling ground rig boom tower, the airplane was subjected to additional tests, including a check of boom operation and fuel transfer system characteristics. General operational stability established, the next step in the testing program consisted of in-flight checks of the refueling boom to determine that the boom is stable throughout the range of normal operation, to check for the proper stick-free position of the boom, and to determine the control envelope and forces at a given airspeed and altitude. At high altitudes and speeds, boom stability investigations and flutter checks were conducted. With the boom extended 10 feet, studies were made of the control envelope, as well as the usual in-flight functional checks of the boom. The proof of the pudding of the KC-135 took place on October 3rd, 1956, when it participated with a B-52 receiver airplane in a series of refueling contacts. Operation of the refueling system in various modes was accomplished, with upper limit, lower limit, and right-hand azimuth limit disconnects. Disconnects were also made from the receiver pressure switch. Following these Phase 1 tests, this first KC-135 and the next 8 production aircraft will be subjected to further investigations, comprising an entire Air Force phase test program and directed toward proving the KC-135's operational suitability and capability. Tests conducted to date effectively demonstrated that jet-age flight refueling is a reality. The KC-135 and the B-52 can be flown at identical altitudes and speeds without penalty to the performance of either. Thus, the KC-135 will serve to erase limitations to B-52 range. The KC-135 jet tanker is a striking demonstration of the growth and development being poured into today's Air Force, providing a sure guarantee that American aviation will not be left behind in today's jet age.